In this video, you will learn how to find the position equation of an object for vertical motion. Alright, we're given here this problem, an object moving vertically at the given heights at the specified times. This one. Find the position equation s equals 1/2 at squared plus v sub 0 times t plus s sub 0. So we're given here different heights at different times. So at t equals 1 second, the height is 128 feet. And then at t equals 2 seconds, the height is 80 feet. And at t equals 3 seconds, the height is 0 feet. Okay, let's take note that the standard form of the equation is just s of t equals at squared plus bt plus c. So the first thing we do here is we solve for the values of a, b, and c, and now we can write or find the position equation. So let's do that. Alright, so at t equals 1 second, and then s equals 128 feet. So s of 1, using this standard form of the equation, is a times 1 squared plus b times 1 plus c. And s of 1 is equal to 128, so we substitute that here. So this is just a plus b plus c. So this is our first equation. Then at t equals 2 seconds, and then s equals 80 feet. So s of 2 equals a times 2 squared plus b times 2 plus c, and s of 2 is given as 80 feet. So 80 equals 4a plus 2b plus c. So this is our second equation. We have three unknowns a, b, and c, therefore we need three equations. And then at t equals 3 seconds, and then height of 0 feet, our s of 3 equals a times 3 squared plus b times 3 plus c, and this is just 0 equals 9a plus 3b plus c. So now we have three equations, and we can use elimination and substitution to solve for the values of a, b, and c. Right? So these are now our three equations, and now we use elimination and substitution. So we can solve, we can equate or solve the first equation and the third equation first. So that would be 128 equals a plus b plus c, 0 equals 9a plus 3b plus c. Then we subtract to eliminate c. Okay, this cancels out. Then we have 128 equals negative 8a minus 2b. So this is now our fourth equation. And then we can solve 80, the second equation and the third equation. 80 equals 4a plus 2b plus c. and 0 equals 9a plus 3b plus c. We subtract to eliminate c. And we have 80 equals negative 5a minus b. So now we have the fifth equation. Now we can solve these two equations here to solve for either a or b. Right, so those are our equations, and then we can solve equations 4 and 5. So it would be 128 equals negative 8a minus 2b. 80 equals negative 5a equals b. So we can eliminate b here because it's easier. Just have to multiply the fifth equation by 2. So this would become 1 negative. We multiply this by negative 2. So negative 160 equals 10a minus plus 2b. And then we copy this. 128 equals negative 8a minus 2b. Then we add the two equations to eliminate b. And we have 128 minus 160. So this is just negative 32 equals 2a. Now we can solve for the value of a by dividing both sides by 2. Therefore, the value of a is equal to negative 16. Now we can solve for b. So we can use the fifth equation to solve for b. Solve b. So that would be 80 equals negative 5 times negative 16 minus b. So b is equal to negative 15 times negative 16 is 80. 80 minus 80 is equal to 0. Therefore, the value of b is equal to 0. Alright, so we now have the values for a, which is 16, then b equals to 0. Now we can solve for the value of c. So we can use either of the three equations here. So let's use 128 equals a plus b plus c, and then plug in the values of a and b to solve for c. So negative 16 plus 0 plus c. So this is just 128 plus 16. We transpose negative 16 to the left. And c. So c is equal to 144. Therefore, our equation is just equal to S of t equals negative 16 t squared plus 144. And you can also solve this by solving for the initial velocity and the initial height. Then you will find the same position equation.